I had number 10 on problem set 5, and it said find the absolute value of log a of b minus log b of a if log a of b plus log b of a is equal to radical 20. So what I'm going to start by doing is assigning variables to this. So we're going to say let x equal log a of b. And then we're going to say let y equal log b of a. This just makes it easier to look at. So we're going to rewrite this, and this can be base of a raised to x is equal to b. And this is going to be base of b raised to y is equal to a. So if you take the value of a and you plug it in over here, you get b of y raised to x is equal to b. This tells us that because b is equal to b, that y times x must be equal to 1, because b raised to the first is equal to b. And the same thing can be done over here, and you get a to the x raised to the y is equal to a. So we know that x times y is equal to 1. So this gives us two equations that we can now do a systems of equations on. So we know from the top equation that is given that x plus y is equal to a radical 20. And from this new equation we know that x times y has to be equal to 1. And from this equation we know that x is equal to 1 over y. So then we can sub that into our first equation. So we get 1 over y plus y is equal to radical 20. And we want a common denominator so we can add them. So we know that this is the same as 1 over y plus y squared over y is equal to radical 20. And we can combine like terms. You get 1 plus y squared over y is equal to radical 20. So now you can do cross multiplication, and you get 1 plus y squared is equal to radical 20y. And we want it all on the same side. So you bring it over and you get y squared minus radical 20y is equal, plus 1 is equal to 0. And this is not factorable, so we have to use the quadratic equation. So we get y is equal to radical 20 plus or minus the square root of 20 minus 4 all over 2. And this can be simplified to 2 radical 5 plus or minus radical 16 all over 2. And get y is equal to 2 radical 5 plus or minus 4 over 2. And this reduces to y is equal to radical 5 plus or minus 2. So if y is equal to the positive of this, so you get y is equal to radical 5 plus 2. This means that x is equal to 1 over that value because of this first equation. And you get radical 5 plus 2. And this can be simplified to radical 5 minus 2. And if y is the negative version, you know that y is equal to radical 5 minus 2, which means x is 1 over this value, which reduces to radical 5 plus 2. So get y is equal to radical 5 plus 2, and x is equal to radical 5 minus 2, and y is equal to radical 5 minus 2, and x is equal to radical 5 plus 2. So then we go back to our initial part that we're looking for, which is x minus y. And what is the value of this? So if you take radical 5 plus 2 minus radical 5 minus 2, this goes down to radical 5 minus radical 5, and then plus 2 because you have a minus, a negative, and this simplifies to the absolute value of 4, which is simply equal to 4. Now if you take the opposite of this, you do radical 5 minus 2, minus radical 5 plus 2. Take the absolute value. This goes to radical 5 minus radical 5 minus 2 minus 2, and you get the absolute value of negative 4, which is simply equal to 4. So in both cases, we get that the absolute value of x minus y, because we had assigned x to log of a, b, to x, so we get x minus and then log of b of a to y. So you get x minus y is the same of what we're trying to find, and if you plug in both values that we had gotten in the case of a positive and in the case of the negative of the quadratic formula, you get that the absolute value is equal to 4. And it's the same in both cases because either way that you subtract them, you're taking the absolute value, so the negative and the positive does not matter in the end. So the answer to this is simply 4.